Good evening and welcome to Phoenix Robotics Club's Project Week, Day 1. I'm Shreya N and I'm a member of the club, and today I'll be your host for the evening. So I'd like to start by welcoming you all for today's event. Project Week is all about research, analyze, and create, which is the motto of our club. It's about gaining knowledge and spreading it wide across. I would like to thank every single one of you today for being here and participating enthusiastically. We look forward to all of your presentations. So, without further ado, let's begin today's program. So, the first person to present their project is Shashank S. You can go ahead, Shashank.
Yeah, please give me a minute. Okay. Good evening, everyone. The members of Robotics Club were given some projects to come up with for the project week. Initially, I thought of making something related to an old impact printer or something related to cryptography. Later, I wanted to do something that is of use. So I came up with this one. It's called Waveton. I'm Shashank S from B section. So Waveton is a musical device that produces tunes similar to most of the musical instruments out in the world. But the way it does is very unique and enjoyable. It produces tunes by getting the distance between the sensor and the object placed in front of it. So we know that every note is associated to some frequency. I'm mapping the distance between the sensor and the object to the frequency of a particular note and then passing it to the buzzer to produce tones. I'm making use of two sensors. The first one is used to get the position of the palm, which is placed in front of it, and the second one is used to change the duration of the notes. It will be better understood if we take a look at the simulation and circuit diagram, which I'll be showing later. So there are only three equipments used. The first is Arduino Uno, a microcontroller, a buzzer used to produce tunes, and two ultrasonic sensors. This is the circuit diagram. The first sensor, as I said, is used to get the distance between the object placed and the sensor. The second one is also used to do the same, but it changes the duration of the notes. I'll show you the simulation. So this is the first sensor. If this is the object or the palm, if I try to move it, the tunes will vary. The second one is used to change the duration between the notes. So in reality, we'll be placing our palms in front of this sensor. So by just waving our hands or any other object, we'll be able to produce different tunes with the help of the buzzer. So as seen, unlike other musical instruments, the tunes here are produced without human touch. So just by waving our hands, unique tunes can be produced. Besides normal people, this project can be used by physically challenged people too. For example, the blind people can use as it only requires the movement of hands, and even the ones who don't have hands can use some objects in order to move and produce tunes. Yeah, thank you. Do you have any questions? Or should I present something?
Thank you for the presentation, Shashank. It was very innovative. Next, I would like to
Thank
call
you.
upon Devishri to present her project.
Yeah, good evening, everyone. Give me 2 minutes, I'll present my screen. Yes. Good evening, everyone. Today I'm going to present about a simulation of a ping pong game, which is basically called as table tennis. So, the basic idea of this table tennis or the ping pong game is that two players stand on the opposite sides of a table, and the basic rule of this ping pong game is that the ball must bounce once on the opposite side of the table, and then if the player or the opponent misses the ball, then we'll get a point. So that's how basically a ping pong game works. So for this simulation, the equipment used are Arduino Uno and LEDs, piezoelectric crystal. This crystal will be used as a buzzer, resistors, push buttons, potentiometer, LCD display, and breadboard. I'll explain the usage of each equipment in the next slide. Yeah, so this is the circuit diagram of the project. So as we can see here, there is a push button here. This push button can be used as a start button to start the game, and we can see two push buttons each side. This set of these two push buttons are for the player 1, and these two push buttons are for the player 2. So this push button is will be useful for moving the paddle down. This straight line which is represented here is a paddle for the player 1 will represent it, and this one is for the player 2, and this small white dot is a ball. Okay, and so this will be useful for moving this paddle up, and this for moving this down, and similarly these two for this player. And we can see two LEDs here. If the player 1 hits or wins the game, this LED will turn green and this LED will turn red, and this LCD display will display a message like player 1 won, and it will be same for the player 2. Yeah. I'll explain the working in detail through the simulation later. So this is the working principle which I have explained now, just now. The game will start when the push button is pressed, and when it hits any other surface other than the paddle, the ball will keep on moving in the same direction. And if it hits the paddle, it will start moving in the opposite direction. And if the paddle misses the ball, then the result will be displayed. I'll explain this with the simulation part. Yes. So this is the project. Yeah, it's asking us to press the start button. I'll press this push button. Yeah, we can see that the ball is moving, and the paddle is moving up. It hit the ball. Yes, and if the player 2 misses the ball, it will display like the player 1, which is represented as P1 1, and it will display green here, and it will restart the game again. So that's how it actually works. Coming to the conclusion, we know that we'll use the Arduino for various range of purposes. In addition to that, we can also create games using the Arduino. So we can conclude this from this project. Thank you.
Thank you so much for presenting this wonderful project, Devashri. Next, I call upon Meghana R to present her project.
Good evening. I'll share my screen just 1 minute. My project is a smoke detection system. I'm Megan R. I'm from A section, second year. So I'll start with the introduction. About 2/3 of the home fire deaths occur in home with no smoke alarms or which have smoke alarms and they don't work. So properly installed and maintained smoke alarms are one of the best and least expensive means of preventing an giving an early warning and preventing death due to fires. Working principle of this is that it's simulated online for now. I'll show you the online simulation. A certain threshold value is given to the gas sensor, and it checks if the smoke content is above the given threshold value. During the simulation, the gas sensor detects the presence of smoke and compares to the threshold value. And if it extends the threshold value, then the buzzer starts to ring and the red LED will be switched on, and an appropriate message will be displayed on the LCD. This is the working of the gas sensor as shown in the picture. The voltage that the sensor output will change according to the smoke level or gas level.
There's background noise. We can't hear you properly.
Okay, I'll join with my 1 second.
So, as I was explaining introduction, a smoke detector is a device that senses smoke. It's also known as smoke alarms, and the commercial smoke alarms are electronic protection devices that automatically sense the presence of smoke. I'll explain the equipments in the next slide. The working principle is that the gas sensor takes a certain threshold value, and when the gas sensor senses value above the threshold value, then the red LED rings, red LED switches on, and the buzzer rings. An appropriate message is displayed on the LCD. The working of the gas sensors are shown in the picture. The voltage that the sensor output changes according to the smoke level. So the sensor outputs a voltage, and that is proportional to the concentration of the smoke or gas in the air. Higher output means that the smoke is detected and the alert is displayed. The equipment used are the materials are Arduino Uno, LCD display, buzzer, breadboard, resistors, gas sensors, and LED. This is the circuit diagram. I'll show it in the simulation again. Uh, this is the circuit diagram, and it's showing safe no smoke since the smoke is not in front of the gas sensor. And when I bring it near, the smoke is detected and red LED glows, the buzzer is ringing, and alert smoke detected is displayed. If I remove it, then the green LED is switched on and safe no smoke is displayed. So to conclude, in a fire, the smoke and deadly gases that tend to spread farther and faster than heat. So the most of the victims that die from smoke, they die from smoke rather than from burns from heat. The majority of the fires happen when families are asleep because the occupants are unaware of the fire until there's not adequate time to escape. So a smoke alarm stands guard around the clock, and when it first senses smoke, it sounds an alarm. Thanks.
Thank you so much for the great presentation, Meghna. The next person to present is Chirag, but since he is not in the meeting yet, I'd like to call upon the next person, Vinay Kumar, to present their project.
Yes, Shreya, 1 minute.
Yeah, sure.
Good evening, everybody. Welcome to the Phonics Robotics Club. And I am Madhava Vinay Kumar. And today I'm going to I have taken a topic on social distancing indicator and an alarming system. And let us know the introduction of that social distancing. In this pandemic situation, social distancing has become very important role to tackle this situation. and the social distancing reminder system can be proved to keep the distance between each other. And next, let us know the working principle, and this is the block diagram of an instrumentation system. And this the social distancing automatic alarming system has been developed by using an ultrasonic sensor, and this is a single signal conditioning. And next, it is an analog to digital conversion. If it is a normal distance, it if it is yes, it ends that program. If it is not end, the alarm gets rang. And next, this is an equation how that the working that system has worked. S is equal to velocity into time divided by 2, and this is an equation if the distance of this object or a velocity of the sound wave, the time required for the propagation, it calculates this equation. And next, the equipments that are used: Arduino UNO R3, and next is an ultrasonic sensor, NeoPixel Ring 12, piezo buzzer, and a breadboard. These are the 5 important equipments that are used in this project. And next, let us know the components that what does do. Sorry. Next, Arduino UNO is an open source microcontroller board based on this microchip at Mega 328 pixel microcontroller and developed by Arduino CC. This is an unlock to digital input and output pins that may interface to various expansion boards. And let us know next is ultrasonic sensor, an ultrasonic sensor that measures distance between uh, by using ultrasonic waves. And next is this is an LED 12 ultra bright smart LED neopixel are arranged in a circle with 37 outer diameter, and the rings are chainable connect the output pin of one to the input pin. Next is a piezo buzzer. Piezo buzzer can generate basic beeps and tones. They work by using the piezo crystal, and it can generate a pressure wave which a human ear picks that sound. And next is breadboard. The breadboard is make a quick connection between the components of a small sockets on them. And this is a circuit diagram. Let us understand by seeing this simulation. And let us assume this is as a person. If a person has kept this project into in his or any ID like ID card thing, if a person is near him, we can see in LED a light is getting brightened, and it got buzzed if a person is near him. And this is the simulation. And next is conclusion. By using this product, our community spread of virus can be diminished as it ensures the proper maintenance of distance among individuals. This is by concluding. Thank you.
Thank you so much for presenting your project, Vinay. It was very informative. Next, I'd like to call upon Chirag to present his project.
Thank you.
Chirag, are you there? Okay, Chirag might have some technical issues. Meanwhile, we can go ahead with Janvi. Are you there?
Yeah, I'll just present.
Yeah, sure.
Hello.
Yes, Chirag. Janvi is going ahead with the presentation. So is it fine with you to do it after her?
Yeah, okay, okay, no problem.
Okay.
Good evening, everyone. Today I'll be presenting about digital thermometer in Arduino. So in Arduino, we can construct a digital thermometer using one sensor, which would be the TMP36. It is the temperature sensor, and the Output will be shown using an LCD screen. Here the working principle is that the temperature sensor will measure the temperature of the surrounding and the Arduino will convert it into the Fahrenheit corresponding Fahrenheit value. And then this output will be shown in a 16 into 2 LCD screen. The equipments used are Arduino Uno R3, breadboard, potentiometer, resistor, temperature sensor, LCD screen, and connecting wires. This is the circuit diagram. So this is the curve. Here we have taken a variable degree and real degree, which are both initialized to 0 in the void setup. In the void loop, we can see that the value, whatever the temperature sensor will measure, is red. And using these formulas, it is converted into the corresponding Fahrenheit value, and it is displayed in the LCD screen. So we can see the temperature is recorded over here, and this is the temperature sensor. We can change it. The potentiometer here is used to change the resistance in the circuit. So digital thermometers are very accurate and safe to use. This so Arduino-based digital thermometer can be used for measuring precise temperatures in laboratories, incubators, storage rooms, etc. Thank you.
Thank you so much for the presentation, Janvi. Chirag, you can go ahead.
Yeah, thank you. Hello. Hello.
Yes, Chirag, it's visible.
Yeah. Today I'll be talking about like how can we make a piano using an Arduino board. So basically, this is a musical device that produces different sound of a different pitch so there are 7 push buttons, and at each push button we press on, there'll be a different pitch of sound, and not even sound, there'll be a different like color also using RGB LED. So the working principle directly, I'll be showing you about using a simulator. So this is actually the a piano which I have made using the Arduino Uno. So the components you can see are the Arduino Uno and RGB LED, buzzer, and breadboard with 7 push buttons and resistors. So let me start with the simulator, by starting the simulator. So this is how it basically works. So every time we press the button, there'll be the sound will be emitted from the buzzer, which is of different pitch. So the different pitch, it depends upon the different buttons. For example, you see when you see the starting button, there'll be a different the sound emitted from the buzzer is of different pitch, whereas the third button, pitch will be different when compared to the first button, and you can also see the change in the color in RGB LED as we go on pressing like all the buttons, all the 7 buttons present here. So let me explain you the code which is involved in making the piano. So the code which actually involved in the piano is similar to that of the C programming code. As you can see, all the constant integer type button and void setup and void loop. So let me explain you from the first very fastly. And as you can see that node A and 262 and node B is initialized with 294 and node C initialized with 330 and node D initialized with 349 and all the etc numbers. These are actually the frequency which actually changes the pitch. For example, note A, as you can see here, as you can compare the note A here. This is of the button A. So it is initialized to the note A that the button A should emit this particular sound of this particular frequency and this particular pitch when pressed on. So and again when we come down we can see that the FISO buzzer here. So this buzzer you can see it is initialized to 5. So the reason it is initialized it is initialized to 5 because you can see here in the Arduino board that the wire is connected to the wire is connected to the fifth terminal of the Arduino board, and so on. Okay, when you go down, you can see that the button A, button B. So these are the buttons you can present here. So these buttons are connected to the A0, A1, A2, A3, and A5 terminal of the Arduino board. But when you see the last button, which is the seventh button, since there is no space in the Arduino board, which is until the A5, it is connected to the fourth terminal of the upper half of the Arduino board, and when you go on, there's like a void setup. So these are the outputs. So the output pin mode, which is 11, 10, and 9, you can see it here. These are for the RGB LED, where this is 11, 10, and 9. Since RGB LED name suggests red, green, and blue, we are connecting here the red wire, the blue, as well as the green wire here. And when we go on checking the further and when we go on checking the pin mode input, such as button A, B, C, these are the input we are giving. That is the press the pressing of the buttons, which is nothing but the input. So since I said you the starting only, this involves somewhat C programming type, that is the void main as well as the void loop. So there is a loop program here which controls the Arduino board. So this loop button is if the input we are given or the button we have pressed equals like the button A, then we have to send the tone of that particular C frequency, and the Arduino and the RGB LED has to glow the red color. And if it is given to the button B, we have to like the Arduino board will send the frequency of the frequency which is involved with the button B, and similarly it goes on with all the 6 buttons. The other interesting thing I tell you about this is the 100 which is given here. This is nothing but the time, the extent with which it should carry on the sound. For example, this is like 100 milliseconds. So if we increase this 100 with 1000. One minute. Yeah. Yeah. I got to know now. And if I start the stimulation now, it's initializing. And So since you have seen the screen, like it went for like prolonged time. That means it goes on for 33,000 milliseconds until it stops. Whereas at the third button, it goes for 100 milliseconds and then stops immediately. And when I show you once again, so this is the actually logic which is involved behind this code. So you can also see all this red, green, blue, and raspberry involved, which is written in the code. So this is nothing but the color which is shown by the RGB LED, and and you can again see the void set color which is 11, red, 9, and 10, which basically nothing but the RGB LED which is connected to the 11th, 10th, and 9th position, and this is the end of the program. And yeah, that's it. This one. So the material use has shown, it is used by the Arduino. The materials used are Arduino Uno, buzzer, resistor which is of 10 ohm resistor, and RGB LED, as well as a breadboard. So this is the circuit diagram which is shown in the simulator earlier. So the conclusion is everyone can have piano, and yeah, so they may look for even though this is not, this does not emit has desired sound as of the normal piano, but improvisation can make the suitable things. So thank you.
Thank you for the incredible presentation, Chirag. I guess that's it for today. Once again, I'd like to thank you all for participating in the project week. We have all learned a lot by not just making the projects through the online simulator, but also we've contributed and shared knowledge through the presentations that we've gone through today. So I'd just like to say the thank you.